Just as a reminder, we have three different forms that our equations could be written in. We have standard form, which is a times x squared plus b times x plus c. So if you have an x squared and an x and a constant, that would be standard form. When it's in standard form, to find our axis of symmetry, we use negative b over 2a. So that's find the axis of symmetry, and it's the first number in our vertex. Next, we have vertex form. So that's a times x minus h squared plus k. So this is vertex form, where our vertex is h comma k. And then the third one is intercept form. So that's a times x minus p times x minus q, where p and q are the x-intercepts. And then to find the axis of symmetry, we do p plus q divided by 2. And that's going to be the first number in our vertex. Whatever your axis of symmetry is, that's the first number in the vertex. So looking at the first one, is this in standard form or intercept form? Standard, perfect. So it's in standard form. That means to find our vertex and our axis of symmetry, we have to use negative b over 2a. The only thing is here, I have an x squared term and I have a c, but I don't have an x term in the middle. I'm missing that b. So what do you think my b is? 0. Awesome. So it'd be negative 0 over 2 times, what's my a? 1. So 2 times 1. So it'd be 0 over 2, which is what?
0.
Just 0. So what's my axis of symmetry?
0.
X equals 0. Don't forget that x equals. If you don't put it, you'll lose points. Axis of symmetry is always x equals. What's the first number in my vertex? 0. How do I find the second number in my vertex? Plug in 0. So I plug it into the x. So I have 0 squared plus 2, which would just be 2. So the second number in my vertex is 2. So I'm going to go to my graph, stay at 0, and go up 2 and put a point there. How can I find another point on my graph? Choose a number close to my axis of symmetry, so something close to 0. So I can plug in a number close to the axis of symmetry. So what's a number close to 0? 1. Sure, let's plug in 1. So I'm going to plug in 1 into my x. So I have 1 squared plus 2, which would be 1 plus 2, which is 3. So I plugged in 1 and got 3. So that's another point on my graph. So I'm going to go to my graph, go to the right 1 and up 3. Once I have 2 points, do I know where my third point is? The mirror on the other side. So since this is 1 space away on the right, my same point is going to be 1 space away on the left. Once I have 3 points, I can draw my graph. All right. So to decide if we have a maximum or minimum, we have to look at the vertex. Is the vertex at the highest point or the lowest point?
Lowest.
The lowest. So that means I have a minimum. So my vertex is the lowest point. So I have a minimum value. What is my minimum value? 2. It's always the second number from the vertex. So the minimum value is 2. Does my graph open up or open down? It opens up. We can clearly see that it's opening up, but also we know that if A is positive, so A was 1, if A is positive, that tells us it opens up. So we knew even before we graphed it that this was going to open up. All right, now let's look at increasing and decreasing. So we skipped this in the notes, but it's going to be on the quiz, so I'll talk about it now. So when we look at a graph, we read it from left to right. So just like we read a book, you read from left to right. If I was a person and I'm walking along this graph, I'm walking along here, am I going uphill or downhill? Downhill. Going down. So do you think I'm increasing or decreasing? Decreasing. Now I keep walking, I get to the bottom, and now I start walking uphill. Am I increasing or decreasing here? Increasing. So for increasing and decreasing, all we need to say is if we're increasing on the left or on the right. I'm increasing on the right. I said it was on the right. If you need to, write it down so you can clearly see. I wrote increasing on the right, so increasing to the right. So decreasing is to the left. That's all you need to do for increasing and decreasing. All right, so now let's look at the domain. What is my domain? All real numbers. The domain is always going to be all real numbers, which you can abbreviate and say ARN. All real numbers. Domain is always all real numbers. That never changes. It's like a freebie question. If it says domain, first thing you're going to write there, all real numbers. You don't even have to do any math. You just got to remember. All right, and then next for our range. So our range, we're looking at the y values of our graph. So what's the lowest y value that we have here? 2. It's always going to be the same number in our vertex, that k. So 2, the number gets the bracket, and then my graph goes up to what? Infinity. And the infinity always gets the parenthesis.
So it's a bracket, not parentheses?
Just for the number, it's a bracket, but the infinity gets the parenthesis. So whether it's infinity or negative infinity, that part always gets the parenthesis. The number always gets the bracket. So just on the side here, if I had a graph that opens down, let's say my vertex here was at, I'm just making up numbers, so 3, 4. So just to practice our increasing and decreasing, and we're going to practice domain and range here too. So if I was a person walking along this graph, you always start at the left and you read a graph from left to right, just like you read a book from left to right. You read words from left to right. So if I was walking along this graph, I'm going up. So am I increasing or decreasing? Increasing. And then I keep walking, but then I start to walk down. Am I increasing or decreasing? Decreasing. So am I increasing on the left or on the right? On the left. Because I wrote the word increasing on the left part of my graph here. So that means I'm decreasing on the right part. So decreasing would be right. What's my domain here? All real numbers. Always. All real numbers. Now my range. So my graph points down. So what would my range start at?
4.
So you start with the smaller number. So it'd be negative infinity because it's going down. It's going down forever. So it's going down to negative infinity. And then where does my graph stop? 4. So 4, and that number gets the bracket.
So it's going down like
So I have to identify the vertex, describe the transformations of each. So let's start with our vertex. What is my vertex here? Perfect, -2, 7. It's always what you're adding on the inside and what you're adding on the outside, but you always switch the sign of H.
when we're describing
All right, so let's identify our transformations now. What does multiplying by 3 do to our graph? Stretch. It stretches our graph. Because it's a number that's greater than 1. So if you multiply by a number that's bigger than 1, it stretches the graph. We're going to do a negative on the next question. But yes, if it was -3, it still stretches. But I'll show you in the next one. What does +2 on the inside of our parentheses do? Left 2. Awesome. And then what does +7 on the outside do? Up 7. So the transformations you just have to memorize. Know what it means to add something inside the parentheses, outside, negative numbers, and all that. Just for fun, let's identify our axis of symmetry in the first one too. What would my axis of symmetry be? X equals -2. It's always the first number. And it's always, always, always x equals. We're going to do the second one also, just because it has a negative. So looking at the second one on this page, what would my vertex be? +4, -6, because we always change the sign of the H, change the sign of the number that comes from the inside. What's my axis of symmetry? X equals 4. Perfect. Now let's identify our transformations. So a negative being multiplied is its own transformation. What does a negative do to our graph? Reflection. Awesome. Reflection on the x-axis. Since it's outside, it's a reflection on the x-axis. It's outside the parentheses. When you multiply by a number that's less than 1, that's a shrink. So a number in between 0 and 1. So that 1/2 makes our graph shrink.
when we're looking at like shrink and stretch, do we ignore the negative?
Yeah, because the negative is its own transformation. So these are two separate transformations. You have the negative, which is a reflection, the 1/2, which is a shrink. They do not go together. All right. What does subtracting 4 on the inside do? Right 4. Awesome. And then what about subtracting 6 on the outside? Down 6.